and got the title down. Okay. Gaussian elimination. So Gaussian elimination is this method for solving systems, okay, that was made by this guy, Gauss. One of those really, really old dead mathematicians that discovered all this that we now use, okay? And he came up with this very streamlined way of solving a system of not just 3 by 3. Like in college, I did this with systems of like 6 equations, okay? You can solve more, but we won't extend past 3 for us. Okay. So what it involves, and I'm sorry, you don't have to write this down until I go to the lined paper and write. So you can just kind of look at these right now, okay? But what this involves is taking a system, right? We kind of worked with this Thursday and Friday, and changing it from a system to something called an augmented matrix. And all a matrix is an organization of numbers into rows and columns, okay? And if you kind of look at this, all they really did is just drop the x, y, z, right? But you can kind of tell where x, y, and z are because of the way it's organized, right? Like where are all the coefficients of x? Where do you see them? In the first column, right? These are all columns of, this would be the x, so like this is where all of our x's are, right? This is where all of our coefficients on y are. This is where our coefficients on z. And what are these numbers on the right after this line? Where are those coming from? Do we see it? Like, can you tell? Did they just make these numbers up out of the clear blue sky? Where'd they get these numbers from? Yeah, the number after the equal sign. So this line right here, this is what takes this matrix from just a matrix into an augmented matrix. Because in an augment means to extend, okay? Extended. It just means to have the equals inside the matrix with it, okay? So I'm pretty confident if I gave you any system, could you convert it to a matrix? Yeah, you just make it neat, drop the variables, and organize it, right? Okay, so it involves using this instead of a system, all right? Our goal in Gaussian elimination is to take our matrix from where it is now and to turn it into this. So really all we want to do is we want to create zeros in this bottom left corner, and we could have any, let's just use numbers. It could be any numbers over here, okay? Now think about that. If I'm going to change these into zeros, isn't that the same thing as eliminating it, right? Remember what we did like the last 2 days? Eliminating really meant make a zero pair. I tried to like use those words so you know that. Okay, so that's what we're trying to do. We're trying to create zeros down here. And think about what this is saying at the end. This is saying 0x plus 0y plus something z. Isn't this just telling us what z equals? Right? I mean, imagine there's a number there, right? Doesn't that mean z equals something? And then if you know z, couldn't you go back up here and plug in z here and get y? And then if you know that, can't you plug them both in to get x? And that's exactly what you do. You use this method to create these zeros, and then it just becomes one of those upside-down pyramid questions. Okay? Now, how do we do this? How do we make these zeros? Well, there's some legal moves you can make. You can swap rows with each other. You can multiply a row by a number, and you can add one row to another. These two should sound familiar, because that's exactly what you do every time you do elimination. Even worksheet 6 elimination of 2 by 2s, right? You're multiplying an entire equation by something, and you're adding it to another one, right? We're doing that today. We're just only doing that with numbers. We're leaving x, y, and z completely out of the picture, okay? Okay, so let's try one. So now on your paper, can you write down, for example 1, can you write down this matrix? And I don't know why the line kind of like jumped. There should be a full one for here. Okay, really take advantage of the fact that you have lined paper. All right, and I'm going to copy mine down, and then we'll start as soon as we're all copied down. Okay. So let's see. 1, 2. we should have something that looks like this, right? All right, what might be helpful is to write what your goal is. So goal up here is for it to look like number, 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 0, number, 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 0, 0, number, number. Okay. There we go. All right, that's our goal. Okay, so what we're trying to do is create these zeros on the bottom. There's an order that you should go by. You should go this way. Okay? You don't have to start up top and go down and go right, but if you go that order, it's going to work out much better than if you don't. Okay? So I would probably draw this to help you kind of anchor yourself, all right? And all we're doing is trying to change these into zeros. All right, so what you do is you identify where you're starting. So if I go by this, what number am I going to attack first? Can you like pick out the number in the matrix you want to make a 0?
2.
Yeah, we're going to start with 2. So I always draw this little like circle around that number so I'm aware. It helps anchor the rest of this process if you draw that little circle. Okay? All right. Now, we are going to write down a row command, which is like a code basically, okay? Excuse me, of how we're going to take that 2 and eliminate it to be a 0. And that's going to involve multiplying one of these other rows by something and adding it to this row. So can you kind of look at the remainder of the rows and ask yourself, you know, kind of think about what you could do to create a 0 here? Like if I use row 1, what would I need to multiply this by so that when I added it, it would make 0? -2, right? I could multiply that by -2 and then add it here and that would make a 0. That's the same as what we did with elimination. Remember when we say take this whole equation times a number, right? It's just that these aren't equations anymore, these are rows. So I could take all of row 1 times -2 and add it here, and that would eliminate it, right? Couldn't I also do the same thing with row 3? Because it's the exact same number. So I have 2 equally as difficult or easy operations. I would just look at the rest of your numbers and say, which would I rather multiply, the top row or the bottom? I don't know. I might pick the bottom because there's more ones. Okay? But here's what we would write. We would write this. -2 row 3 plus row 2 into row 2. Okay? I'll just have you write that down first, and then I'll explain where this coding is coming from. So this is saying, in order to put a 0 here, where I want it, I would have to take all of row 3, because I can't just pick, right? I have to do the whole row, times -2, add it to row 2, and it's going to replace my row 2. Couple things. I always write my row command on the same line as the number I'm attacking. That just helps me organize everything better. Okay? All right. So I'm always replacing whatever row I've circled. If I've circled row 2, I'm replacing row 2. When I get to these, I would be replacing row 3, right? All right. Now what I do is I set up a new matrix, and anything I'm not replacing, I just copy. So I have not changed row 1, so I'm just going to copy that down. And I have not changed row 3, so I'm just going to copy that down. Row 2 is being changed. It's being replaced. And to figure out how we replace it, I have to follow the command. I gave myself an order. I have to follow it. So this is saying take -2 times row 3. So I'm going to start, here's row 3, right? -2 times row 3. So I'm going to start with this number, 1. Negative 2 times 1 is what? Negative 2, right? So I'm going to write a little negative 2 down there. This is just going to help me do my math. And then I'm adding it to row 2. Well, what is row 2? 2. Now I just add those two numbers together. What's negative 2 plus 2? 0. And then I'm replacing row 2 with that. So I'm taking this little space here to go ahead and do my math. Okay, now I repeat the process. Now I move on. Negative 2, row 3, so that would be this number. Negative 2 times 1 is negative 2. I'm going to add it to row 2. Row 2, I have a negative 2. And I add those two numbers together. Gives me negative 4, right? Okay. Now I keep going. Negative 2 times row 3, so negative 2 times 2 is negative 4. Plus row 2, so plus 1. And I add those two numbers together, and I get negative 3. So what I'm doing with my left hand when I'm pointing, it's not that I'm totally doing that to teach you. Every time I do this myself, I have to point, because I have to know where I'm going, right? Negative 2, row 3. So negative 2 times negative 4 is 8. Adding that to row 2, which is 7. 8 plus 7 is 15. Okay? So through that command, I've got that 0 there. Does that kind of make a little bit of sense? The actual arithmetic, I know we got to practice that, but does that make sense how that 0 came to be there? All right, now you ask yourself, all right, what number's next? What number is next that we want to make a 0? That 1 in the corner, right? So I draw my little circle because that anchors my command, right? Okay, and I ask myself, how am I going to make this disappear? There's a formula for figuring out your commands. So maybe you should write it here. The formula is multiply, add, and replace. Multiply, add, replace. So I multiplied a row, added it to another, replaced it into a row. Okay? That's your formula to set up your command. All right. What row are we replacing? Row 3, right? The bottom row. So whatever command I'm writing, I'm going to write it here. Now we just have to ask ourselves, what other row am I going to combine it with? Row 1 or row 2? Yeah, it has to be 1, right? Because I can't multiply 0 by anything that's going to be able to make a 0 pair with 1. So what would I multiply row 1 by? That will make a 0 pair when I add it to this one right here. Because right now, 1 plus 1 is 2, but I want it to be 0. So what am I going to have to multiply this by? Negative 1. So it's going to be negative row 1, because I don't have to write negative 1, right? Plus row 3 into row 3, right? That is what's going to make a 0 in that spot. I don't care about the other numbers, right? All I care about is the one I'm focusing on. All right, so I'm replacing row 3, so my next matrix, rows 1 and 2 don't change. We can just copy them down. Okay? All right. Now to fill out row 3, I follow the command. All right? The command says take negative row 1, so I start up here, right? Starting with, this is row 1. Negative 1 is obviously negative 1. And I'm going to add it with row 3, which is 1. Negative 1 and 1 makes 0, right? Goal. We wanted that 0 there. All right, now we keep going. Negative row 1, so negative 2 plus row 3. My row 3 is the number 1. I add those two numbers together. Negative 2 and 1 makes negative 1, right? I'm just doing arithmetic, right? Okay, now keep going, negative row 1. Okay, now look. Negative row 1. So that'd be negative, negative 3. What's that going to be? 3. It'll be positive 3 plus row 3, which has a 2 in it. And we add those two numbers together. 3 plus 2 is 5. Negative row 1, so negative, negative 2, which is 2, plus row 3, which is negative 4. Add those two together, you get negative 2. Okay, so you're just following the row command. Questions so far? So we got to do this one more time. All right, what's the number we're attacking last? It's negative 1, right? Okay, so we have to ask ourselves, what could be the row command? And I'm going to put it here on the third row because I'm replacing row 3. But here's where I have to be careful. Because at this step, I cannot combine it with row 1. You would know why I can't combine it with row 1? Has to do with, like, what's over here. Yeah, because of this 1. No matter what I do, if I use row 1, I'm going to be adding and putting a number here. And I worked really, really hard for that 0, right? Okay, so I don't want to use row 1. So here's a good note. At this point, you can't use row 1. Maybe make that note to yourself at the third time. Let's put our phones away. We don't have them out. Okay, so I can't use row 1, so I have to use row 2. Okay, now look. I want to turn this into a 0. I can multiply the negative 4 by something, or I can multiply the negative 1 by something. Do we have any ideas? I want to add them together, and I want that to turn to a 0. So I have to get these to be the same number, 1 positive, 1 negative. There's different ways you can do this. Well, what could we do? Yes, ma'am. Exactly right. Yes. You could multiply this one by negative 4. Because what's negative 1 times negative 4? 4. You could combine them, and then it's 0, right? Does everyone see that? Or, and this is the harder one that you could do, but it would be harder. You could take row 2 times negative 1/4 and make it a 1. But I don't want to do that with 3 and 15. But yeah, it's exactly what we do here. So this time we're multiplying row 3. So I could say I want negative 4 times row 3. What row are we adding with it? I'm multiplying row 3 by negative 4. I'm going to add to it row what? Row 2. Yep. But I'm replacing this value into row 3 because that's the row with the little circle. That's the one I'm replacing. Whoops. R3. I don't know why I wrote 3 there. Row 3. Little 3. Right? Sorry about that. Okay, that's going to bug me. There we go. Okay, so 1 and 2 are not changing, so we're just going to keep it the same. So 1, 2, negative 3, negative 2, 0, negative 4, negative 3, 15. Okay, when it gets to row 3, that's where we have to do this math. So we just go piece by piece, okay? Negative 4 times row 3. Here's row 3. Negative 4 times 0 is 0. Adding it to row 2, 0. Add those, I get 0. That should happen, right? Okay. Then we move over. Negative 4 times negative 1 is 4. Add it to row 2, which is negative 4. That makes 0. Great. That's what we wanted. Move on. Negative 4 times row 3. So negative 4 times 5 is negative 20 plus negative 3 makes negative 23. Negative 4 times negative 2
is 8 plus row 2, which is 15. 8 and 15 is 23. Okay, so at this point, Gaussian elimination is done. We've got our goal matrix. It is actually possible to keep this process up all the way till the final solution, but we don't have to do that right here. So what you can do here is now you can turn this back into a system. You threw it in a matrix to get it down here, but you can write it as a system. Remember that all of these numbers are the coefficients on x, y, and z. They're not the values of x, y, and z. They're the coefficients. So our system would be x plus, this 2 means 2y. That minus 3 means minus 3z. That big long line, remember, was our equals, negative 2. And then our second row, that's 0x, but I don't need to write 0x. I'm just going to, not put anything there. That'll be minus 4y. And then that minus 3 means minus 3z equals 15. And then the final row, 0x, 0y, is negative 23z equals 23. So we took something that was like full, right? And we kind of got it to this. Now does this look like something we can solve pretty easily, like we did on Thursday? Yeah, I mean, can you look at that and know what z is? I hope. What's z? Divide by negative 23. What's 23 divided by negative 23? Okay, maybe let's throw that in the calculator then. Solve it. 23 divided by negative 23. Ask the almighty calculator. What does it tell you that is? Negative 1. Right? Yeah, come on. Right? All right, that's z. Great. Which variable can we find next? Y, right? Y'all practiced this on Friday where you went backwards, right? Okay. So now I can find y. So I'm going to find y now. Find y. I plug in negative 1 for z. So negative 4y minus 3 times z, which is negative 1, equals 15. And I just solve that through, right? Negative 4y plus 3 equals 15. Minus your 3 from both sides. Oops, that's negative 4y equals 12. So what is y? Negative 3. Okay, we have z, we have y. Only thing left to find, x. So you plug them into the top, right? So I'm going to find x. So plus 2 times y, and y is the number negative 3, right? Minus 3 times z, which is the number negative 1, equals negative 2. So this is x. 2 times negative 3 is negative 6. Negative 3 times negative 1 is plus 3. Negative 6 plus 3 is minus 3. Add 3 to both sides. X equals negative 2 plus 3 is 1. Solution set. 1 is x. Negative 3 is y. Negative 1 is z. Okay? So the Gaussian elimination part, the new piece, right? Your 3-row commands. Then it's a problem you can use substitution to solve. So this up here is just another way from doing essentially what you did on the desk on Friday, that 3 by 3 elimination. Okay? We're going to do this again for practice, But are there any like specific questions that I can answer right now before we try it again? And we'll try to go a little quicker the second time. But any questions I can answer about this one? No? None? Just want to try it again? Okay. Try this. On your paper, so you're going to have to probably flip, right? I need a new page. Can you copy this system down, but when you put it on your paper, can you convert it straight into a matrix? So like read it as a system, but write it as a matrix. Can you do that? You drop the X, Y, Z, and you have your line? Right? Yeah. Okay, try that, okay? Write it down, and then we'll get started on all the commands. So, like, one of the questions on your next quiz is to do this, not to do all the Gaussian, no, to take a system and write it as a matrix. So, by practicing this right now, that's like a whole quiz question that we can nail right now. Actually, I should probably do it if I want to be ready, right? Let me get mine down. Okay, we all get, whoops, nope, that's not what I want to do. All right, we all get that down? Mm-hmm. Yours look like mine? Mm-hmm. All right, if you could do that, that's a whole question on a quiz you could get right. All right? Okay, so let's see if we can go quicker. What is the number I'm going to attack right now? 2. All right, draw my little circle. That means the row command I'm going to write is going to go on this second line here. Okay? Which row do we want to combine it with? Row 1 or row 2? Yeah, row 1. What are we going to do to row 1? Multiply by -2, right? So the row command will be -2 row 1 plus which row? I'm multiplying row 1 by -2. I'm going to add that to row 2. Replace row 2. I'm always replacing the row I'm writing on, the row with the circle. Okay? All right. Next, you fill in any row you're not replacing. So that would be 1 and 3. You straight up copy it. Just copy it. 1, 2. Okay. Okay. Now to replace it, that's where we have to do the math, and we got to go piece by piece. So -2 times row 1. So here's row 1. Okay. -2 times 1 makes -2. Right? And we're going to add that to row 2, which is 2, and that makes 0, which was the goal, right? All right, then you move on down the line. -2 times the next one, so -2 times -2 is +4, plus row 2, which is -3. 4 and -3 make 1, right? Okay, move on down the line. -2 times -2 is 4, plus row 2, -5, is -1. And one more. -2 times row 1, so -2 times 6 is -12, plus row 2, which is 7, makes -5. All right? Okay. All right. What number are we attacking next? 3. All right. We can't use row 2 because there's a 0 above it. All right. So in this step, I have to use row 1. Anyone want to take a shot at the row command? -3 R1 plus R3. Oops, I ran out of room. Into R3. Forgive my horrible thing. Yeah, -3 times row 1 plus row 3 into R3. So I'm not replacing 1 or 2, so that just gets copied. Negative 3 times row 1. So negative 3 times 1 is negative 3 plus row 3, which is 3. Add that together, we get 0. So negative 3 times row 1. Negative 3 times negative 2 is 6 plus 4 is 10. Negative 3 times row 1 is another positive 6 plus row 3, which is 1, which is 7. Negative 3 times 6 is negative 18 plus row 3, which is 2. Negative 18 plus 2 is negative 16. I just took negative 3 times each of these, added it to our row 3. All right, we'll have to do one more time. We got to get rid of which number now? 10. And remember the deal with the third and final one. Which row am I not allowed to use? I can't use row 1, I have to use row 2. So, we want to take a shot at the row command? I have to make 10 be eliminated. What am I going to multiply? I'm down to only this one. What am I going to need to multiply that 1 by? Negative 10, right? Negative 10 times our what? What row would I be multiplying the negative 10 by? 2 plus row 3 into row 3. This into row, you should never have to really think about that because that's always going to be whatever line you have the circle, okay? All right, the other two that I'm not touching, they just get copied. Okay, so negative 10 times row 2. So negative 10 times 0 is 0. Add it to row 3 is 0 is 0. That was supposed to happen, right? Negative 10 times row 2. So negative 10 times 1 is negative 10 plus row 3, 10. That makes 0. Yay, there's our zeros. Okay. Negative 10 times negative 1 is positive 10, right? Row 3 is 7. 10 plus 7 is 17. And negative 10 times negative 5 is 50, right? Positive 50. And then row 3 is negative 16. So 50 and negative 16 makes 34, right? Okay. We have our zeros, right? We now have something that's easier to solve. The system we have left now is 1x minus 2y minus 2z equals 6. Remember, these are the coefficients, right? 0x, so 1y minus z is negative 5, and 17z equals 34. Now we can solve that, right? Okay. Starting with z. Divide by 17. What is z? 2. Z is 2. I'm going to find y. I go right back up, bottom to top. So y minus, 2. Because 2 is what z is. Every time I'm plugging in a number, I always use parentheses to show that I'm substituting a value, right? Doesn't mean I always need them, but I always write them anyway. Equals 5, or negative 5. So then I would add 2. So y equals negative 3. And then we just need x. So we go up to the top and plug in those numbers. So x minus 2y, and y is negative 3, minus 2z, so 2 times 2 equals 6. So that's going to be x plus 6 minus 4 equals 6. 6 minus 4 is 2, so x minus 2 equals 6. Add 2. X is 8. Why does that not feel right? Yeah, no, that's it. It just seems weird to me. Okay. No, that is wrong. That is wrong. Because this should be a plus 2. I'm like, that wasn't the right answer before. This should be, because 6 minus 4 is a positive 2. So we'd subtract 2 instead of add 2. So x equals 6 minus 2 is 4. There we go. That's more correct. So this was what the error was, I assumed 6 minus 4 was negative 2, and it's 2. So that changed that to a minus 2. 6 minus 2 is 4. Now we have our solution. X, Y, Z. Questions? Questions, anybody? Anybody questions? Okay. Okay, so let's talk about how you might see this